So hey everyone, welcome back and I hope you guys are doing well. So today we are going to discuss both the LeetCode contest, weekly contest 490, not this one, like weekly contest 489 and bi-weekly contest 176. So let's start with a weekly and then we move towards the bi-weekly contest, right? So let's see the first problem. So what the first problem is? So it's an easy one problem. It's quite easy, and today I would rate this contest as easy because most of the problem are really easy, not that much difficult. Apart from the third and the apart from the fourth and the third are a little bit difficult, not that much. But if you have solved some standard problem, or maybe solve some sheets, you're probably able to solve most of the problem in the contest, right? So let's see the problem. It's quite easy. You are given an array bulbs of integer between 1 and 100. There are 100 light bulb number from 1 to 100. All of them are switched off initially. Make sure to note it down. For each elements bulb I in the array, if bulb I is currently off, switch it on, otherwise switch it off. Okay, return the list of integer denoting the light bulbs that are on in the end. Sorted it ascending order. If no bulb is on, return an empty list. Okay, so what they are saying is, like, initially all the bulbs are off, right? So the example is the bulb 10th bulb is currently off, we switch it on. Then the 30th bulb is off, we switch it on. Then 20th bulb is currently off, then we switch it on. Then again we get a 10th bulb, it is on that like we already on that, then we switch it off. So in the end we only have two bulbs which are on, right? So this is what we have to return in ascending order. So it is pretty easy, nothing fancy. What we have to do, uh, let's see over here. So these are the elements which is nothing but denoting of bulbs, right? And initially all are off. This is the initial condition, and all are off. And what we have to do, if the bulb is off, we turn it on. If it is on, then we turn it off, right? So initially all the bulbs are off. So let me just put it off, off. We only have three bulbs, right? Because 10th is just like a duplicate for because 10 is duplicate. Let's copy it, paste it over here, right? So this is the initial state. What we have to do, if the bulb is off, we have to make it on, otherwise we have to make it off, right? So this is what the normal thing which we have to do. So how we can actually approach it, right? So the simulation is quite easy. That for the first time when we saw the bulb, we make it on. If the second time we saw, we make it off, right? Then we repeat this process until no more bulbs are left, right, of that particular bulb, right? So how can we achieve it, right? So we just have to make sure, like, if you see uh, initially, if the let's say if the array is like this, right? And I ask you what's the number of elements which are going to be or like what the number of bulbs which are going to be on. So you would say three bulbs are there. Why three bulbs are there? Why? Because all the bulbs initially off. You came to 10, you make it on. You came to 30, you make it on. And you came to 20, you make it on, right? So there is no duplicate element, right? So if the arrays look like this, then the answer should be 3. But what if there is another 20? Then what will happen? Initially you make 20 on, but when you see 20, then you make it off, right? So what it become off, right? Because you have second 20 over there, right? So what it can make it, right? Like, now we only have two bulbs, we satisfy the condition, right? So this is what we have to achieve. So if you see, we are actually dealing with frequencies, right? If other number become duplicate or there are more frequency, that is going to define what the current state, like what's the state of the bulb will be, right? So this is what we have to do. So if you see, if what if, like, as you see that if there is a 2 occurrence of 20, then it is off. What if I add one more, right? Then it guess for the first time it is off, on, right? Let's update it on. Then second time it is off, then third time it is on, right? So which means we are just only care about the number of frequencies. And if the frequency is odd, like if frequency, you see, if frequency is 2, then it is always off, right? And if frequency is equal to 3, it is always on, which means we are actually concerned about the even and odd number of frequencies, right? If the frequency is even, then the bulb is always going to be off. If the frequency is odd, then it is always going to be on, right? So this is what we have to do. So we simply do what we do. Like if you see, they ask us to return in ascending order, right? Sorted in ascending order. And if you see the constraint are pretty low, so what we can do, we can just simply create an array of 100 size, 101 size, you can say. So this is going to be array from 1 to 100, one size, right? And we treat the bulb value as a index, and we just increment the count of that particular bulb. Let's say there is 10 and then 20, like then like not like that, like 10 for example. I'm just marking indexes as this one, 30, right? So these are the indexes which is represented the array elements. And if you see, the 10 is 2, is 1, and 3 is also 1, right? So these are the frequencies. So if we simply check if it is even, then it is not going to be a part of our answer. If it is odd, this is going to be a part of our answer. And you see, we have make it in a sorted order so that we don't have to sort it manually, right? So this is what we have to achieve. So this is pretty easy problem, just little bit of if you think, then you are able to solve it. So what we are doing, I just created a array of 101 size, iterating over the bulb, incrementing the value, which means I'm just counting the number of time it occurs. After that, I'm just creating my answer if it is greater than 0, so that we don't include that part. And if it is odd, then it is going to be our part of our answer, right? So let's just run it. So this is quite easy problem. It's also my very easy. So yeah, you see, this is the approach. And talking about the time complexity, you can pin down the comment section what will be the time complexity and space complexity for this particular problem, right? So let's move to the second problem. So second problem is also pretty good. Initially I thought I thought about the different approach because I haven't read problem more properly. But later on, when I understand this problem more better, then I got to know that okay, this is what I have to do, right? So let's understand the problem. Like you are given an integer or a nums, return an integer denoting the first element scanning from left to right in nums whose frequency is unique. Okay, that is no other integer appears the same number of times in num. If there is no such element, return -1. This is pretty, like, it's straightforward, like this is fancy over here, right? So if you see, if we consider this particular example, then what it is saying is that we have to return the first element which frequency is not its frequency is unique. So this is what we have to achieve over here. If you see, 20 occur one time, 10 occur one time, 30 occur two times. So if you see the uniqueness of frequency, so 30 is the only element which have a unique frequency. So thus we return what we have to return, we have to return 30 over here, right? So 30 is the only element which is appear unique number of times. So this is what we have to achieve. Let's take a second example. It will give you another idea about the problem. So if you see, so 20 appears, let me, okay, 20 appeared two times, 10 appear one times, and 30 appears three times. If you see, all the elements are appear unique number of times, right? But what we have to do, we have to return the first element with a unique frequency. Thus our answer is going to be 20, because we are iterating from left to right, right? So this is what we have to actually achieve in this particular problem. So problem is not that much difficult. It is easy to understandable, but it is little difficult for the implementation part, right? So this is what I'm talking about. The yeah, pretty good. So how to actually think about the problem, right? So what's the thing is that here what we are actually, like, here we are doing three things, right? If you see, the first thing, first step you can say, which we are doing over here, is we need a frequency of every element, right? To make sure that, right, first we need frequency of every element, right? And how can we do that? We use a map to store the frequencies, right? So this is the first step which we have to achieve. Second step, what we have to do over here is we got the frequency of we get the frequency of all the elements, right? Now we have to check the unique frequencies, but make sure we are iterating from left to right, right? So how we are going to solve that particular part, right? So you know this particular thing, right? That you know the frequency of every element, right? But we also the only condition over here is that we have to return the first element which have a unique frequency, right? So in order to find a unique frequency, we need some another sort of map where we are actually storing the frequencies, and corresponding to the frequency we store the elements, right? Means what I'm saying over here is that this is the first map which store the frequency because it is mandatory for us, and the second map is going to store the frequency equals to the number of the elements, right, which have that number of frequency, right? For example, 2 contain only 20, this is 1 only contain 10, and 3 only contain 30, right? So this is what we need, another set of map which will actually going to help us, right? And why this is going to help us? Because you see, we have to iterate from left to right, right? And if I am at this particular position, I just have to first find how many frequency it has two number of frequency, and I just went to the another map and check if how many element it has. If it has more than one element, which means it doesn't contain unique number of frequencies, right? So this is what the second map is going to help us, right? And let's say the another case, for example, let's take this one, right? So if you see this one, then 20, there is no there. Let's write it over here, right? One have frequency of 20 and 10, and two has a frequency of only 30, right? So if you see, if I iterate from left to right, if I just check about first I went to 20, I check how many frequency it has one frequency. Went to the another map and check how many element it has. If it is at more than one element, which means it doesn't contain the unique number of elements, right? Then I move to another element, go to 10, then again this. When I went to 30, I got two number of frequencies. I check how many frequency it has. If it only have one, which it means it is the element which I'm actually looking for, right? So I'm just simply going to return this particular part, right? So this is the whole idea behind this particular problem. So problem is not that much difficult, but it is more into implementation part rather than thinking. Let's see the code. It's pretty easy. It is, right? As told you that the same thing which I have been doing over here is first to store the frequency. Make sure to name it more better so that you are also able to understand what the particular data structure is actually doing. Filling the element frequency map, fill the frequency to element, like I'm storing how many elements contain, how many elements have that same number of frequency, and after that I'm just traversing over the array and I'm just checking the frequency of that element, and I'm just checking if it has only one size, that means it is the element which I'm actually looking for. Otherwise I just have to return -1. So this is the whole idea behind this particular problem. uh, Talking about the time complexity, right? So which is O of n we are using over here, O of n we are using over here, and O of n, which is O of n plus O of n, sorry for that, n, which is also going to be like O of n, right? Talking about the space complexity, so which is also O of n plus O of n, which is O of n, right? So this is going to be the time complexity and the space complexity of this particular problem. It's pretty good problem to actually learn about the understanding of data structure and how to use them such that you are able to solve such kind of problem, right? So this is the second question of weekly contest. Let's move to the bi-weekly part. Let's start with the first one. What is the first question? Is pretty easy, straightforward. We just have to do what the problem is saying, nothing difficult. Just understand the problem, then it becomes really easy for to come up with a solution. You are given an array of string word where each string represent a word containing English letters. Okay. You are also given an integer array weight of length 26 where weight I represent the weight of the ith lowercase English letter. Got it? The weight of the word is defined as the sum of the weight of its characters. Okay. For each word, take its weight model 26 and map the result to a lowercase English letter using reverse alphabetical order. The important part, return a string formed by concatenating the mapped character of all the words, right? Okay, which means we have a number of words. We have a weight which contains the weight of the all the lowercase English letter from 0 to 26, right? We just have to calculate their sum and see what the character is going to form. Let's see, ABCD has these particular frequencies, and what's the sum is 34. Then we have to modulo it by 26, which is 8, which means R. If we move from left to right, then R is the element which is at the 8th position. So this is what we have to do over here, is right. So question is pretty easy, nothing more difficult. So what we have to do, we just have let's write it over here. So we have a string, right? Where is the string? So this is the string which we have. So we just have to, oh sorry for that, we just have to process the strings. I will write it as steps. First steps is to process the string while calculating their weight sum, right? And after that, whatever the number, let's say w is the weight sum of that particular thing, then what we have to do, we have to calculate the IND from weight mod 26, right? Because the sum is going to be more than, so we need to find the 26, and whatever the indices is, we have to mark a lowercase English letter from the back, right? So I will write it over here for the first case, A B C. So this is our lowercase English letter 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and so on from the first part, and I just got to a copy and paste. Just have to do from here, which is 0. You will see, like, just okay. So this is the initially thing of the lowercase English letter, and what we have to do first, we have to calculate the sum of these particular character by using the weight, right? So let's say I will the weight of A. The weight of A is, let's just write it this one for ease of use. So the weight of A is 5. The weight of A is 5, and then the weight of B is 3, and right there, the weight of C is 12, and the weight of D is 14. We will do their summation, which is going to be 34. And what we have to do, then we have to find the mod to check what's the element is going to be, and if we do it mod of mod of 26, so which is going to be 8. And what we have to do, instead of picking the element from the front, we have to pick the element from the back, right? So what's the element which is at the 8th index? 0 1 2 3 4 5 7 8. So R is the element which is at the 8th index, right? So this is the operation which we have to perform for rest of the string as well, and after that, whatever the final string is going to build, we just have to return it, right? So this is what we have to achieve. So whatever I've done, this is the same thing which we have to do in the code. Only one thing to make sure is that when you do the division of the 8, then how to get the element from the back, right? So to get the element in optimal way, we just subtract that particular remainder with the 25, that will gives us the indices of that particular character, right? So if we subtract it, so we will get that particular value, and we just simply use the character of that particular index, right? So you see the code that will gives you a better clarity of what exactly I'm telling about. So I just iterating over all the words, calculating the sum by using the weight. I'm just subtracting the sum modulo 26, that will gives me the index of that particular character. I'm just converting it to character and returning it as my answer, right? So this is what we have to achieve. The problem statement is too long, but it's pretty easy, nothing too much, right? So this is the problem is. Just let me know the time and the space complexity in the comment. I will leave it for you. Now the second problem of the biweekly contest is number of prefix connected groups. This is pretty easy problem. Not, I would rate it as easy to medium problem. Right. So let's understand the problem. You are given an array of string words and an integer k. Two words a and b at distinct indices are prefix connected. If 0 to okay, if the prefix is equal, a connected group is a set of words such that the pair of words is prefix connected. Right. Return the number of connected groups that contain at least two words formed from the given words. Words with the length less than k cannot join any group. Make sure to note it down. Duplicate string are treated as a separate words. Okay, got it. And what we have to do, this is the example. Words sharing the same first k two letter are grouped together, which means word 0 is apple and the words 1 is apply. If you see, the first two characters are ap and the ap, both are same, so this is going to part our answer, so we increment the count. And the word 2 and the word 3 is also same because they have this particular thing. So problem is pretty clear. Let's write it over here. So this is the string which we have, and what we have to do, we have to find the pairs, right, which have the prefix equal, right? Make sure what will be the size of the prefix, what will be the size which is 0 to k. This is going to be the size of the prefix which we have to check. And if there is a string which is equal, then it is we just increment the count and it is going to be our answer. And the second thing which should make sure that if the string have length less than k, then it is not our answer, not our part of our answer, right? Not a part of our answer. So this is what we have to do. So we just if you see clearly about this problem, right, what you have to do is we just have to find the strings which have a prefix with length k is equal, right? So you need a pair of elements, right? So, to check if the prefix of the element is equal to or not. So the one brute force approach is to iterate over all the elements. And what I'm saying is from I to n, to n, this is the first loop, and from the second loop from I plus jz I plus 1 to n to, and this is what you have to achieve. And just have to check if this if the current prefix which you have building is a part of your answer or not, right? So this is what we have to do. But this is a brute force approach which is going to be give you a time complexity of n square, and it is also not going to work because the constraints are too high, sorry for that, right? So what we can think of it, if you see, we just only care about the first k prefix, right? We don't care about the whole string of that whole word of that string, right? So what we can do, we only care about the k string, right? Why not we just simply store the frequencies of that, right? What I'm saying is, let's say we have a apple, right? So instead of caring about the whole string, we just only need to care about kth size prefix, right? And we just store it somewhere else, right? For example, if I'm at apple, I just store apple appears one number of time, which means we only have the string which have ap in the prefix, right? Then I move to another string, then I went to apply, and I do the same stuff. I just tag the prefix of k size, and if inside my map or whatever the data structure I'm using, it contains that particular prefix or not. If it is, then I simply increment the count, otherwise I have ignore it. And when I came to banana, then I have another ba which is occur one time, then I came to bandit, then it is also have a ba as a prefix, then I increment the count, right? So if you see, we have a the AP prefix has two elements and BA prefix also have two elements, which means we have total two groups, right? Two groups which total we have two groups which have k prefixes are equal, right? So this is what we have to achieve. So what we do, first step, we just store the k frequencies, like k prefix, in some data structure, and then whatever the element is come, we just increment the count. If it is more than one, then it is just increment the value, otherwise we just ignore it, right? So this is the problem, and I think problem is pretty good, not that much difficult. So whatever I'm doing is I'm just first generating all the prefixes of length k. Here the case, if the length of the string is less than k, then simply ignore it because it is not going to be a part of our answer. And after that I'm just creating a substring of kth length and I'm putting inside my map, and after that I'm just iterating over the map and checking if it is greater than 1, which means we have a more element which is have a prefix as k, prefixes as k length, then we're simply incrementing the count variable, right? And then simply returning the value of count, right? So this is what the problem is. Problem is pretty easy, not that much difficult. The time complexity is O of n and space complexity is also O of n, right? So this is all about the contest problem, right? So, and if you are not able to understand or if you are not able to solve the contest problem, don't worry, just sit down and write the test cases by your own. Understand each and everything, each and every statement which is written on the problem statement. Try to come up with a different data structure that will actually help you to solve this problem and also some upcoming problem, right? Don't get demotivated if you are not able to solve, and if you are able to solve, cheers, you are good to go, you are doing really well. If you're not, then you need more practice. Understand the problem first, went to the hint, then move to the discussion section. If you're not able to solve, then move to our like videos which you are watching, right? So contest problem are really good, that will actually help you to sharpen your LeetCode skills or problem solving skills. So this is all about today contest, and I hope you like, and I hope you are able to understand. If you are able to understand the videos, if you're able to understand the each and every point, then let me know in the comment section, like the video, subscribe to the channel for more such videos. I'll going to upload such more videos in upcoming days. And if you need any particular video of any particular topic, then let me know in the comment section. I would love to make a video on that as well. So this is it for the video. Bye bye and take care.